Welcome to the DIY Honda Garage channel. The DTC P0A94 indicates a DC-DC converter performance problem specifically related to the operation of the DC-DC converter within the Honda Civic 2022 Plus. This DTC is triggered when the powertrain control module, PCM, detects abnormal behavior or failure in the DC-DC converter, which is essential for converting high-voltage direct current to the appropriate voltage needed to power various vehicle systems. If the PCM receives information that suggests a failure, it records this DTC for troubleshooting purposes. The DC-DC converter plays a critical role in maintaining the vehicle's electrical systems, ensuring that adequate power is supplied to components that rely on lower voltage. Owners should be aware this DTC can affect overall vehicle performance and should be addressed promptly to avoid further complications. Hence, the aim of this presentation is to outline the issues and provide a clear troubleshooting guide to resolve the P0A94 error code effectively. The error code P0A94 is stored by the powertrain control module, or PCM, when it detects an issue with the DC-DC converter performance. The PCM is the vehicle's brain, coordinating various electrical components and their optimal functions. An issue arises when the PCM receives a signal indicating a failure in the DC-DC converter, which converts high-voltage direct current from the battery to a lower voltage for various electronic systems. Typical locations where the DC-DC converter is found include near the vehicle's battery and related circuitry. Other related components, such as wiring and connectors, play a pivotal role in the overall system. If there is any malfunction in the detected components, the vehicle may experience electrical instability, leading to further issues if left unaddressed. Therefore, understanding the components involved is vital for a successful troubleshooting process. Several potential causes may lead to the manifestation of DTC P0A94. One of the primary contributors includes a failure in the DC-DC converter itself, which may not be functioning as intended, thereby disrupting voltage conversion. Another cause could involve problems with the wiring harness, such as shorted or damaged wires, which may lead to incorrect signals being sent to or from the PCM. Additionally, issues with the PCM, like glitches or internal faults, could misinterpret or fail to receive the correct data from the DC-DC converter. Each of these components plays an interconnected role in the electrical system of the vehicle. Thus, identifying the precise cause is crucial for effective resolution. By systematically examining these components, technicians can isolate the source of the fault and proceed with appropriate remedies. When DTC P0A94 is present, the vehicle exhibits several symptoms indicative of the underlying issue with the DC-DC converter. One common symptom includes warning lights illuminating on the dashboard, particularly the check engine light, alerting the driver to a malfunction. Furthermore, there may be noticeable electrical system instability, which could manifest as erratic behavior in electronic components, such as lights flickering or unusual sounds from the electrical system. Reduced vehicle performance is another significant symptom. The vehicle may struggle to maintain power levels, affecting acceleration or functionality of other vehicle systems. If left unchecked, these symptoms may worsen and lead to further electrical issues, making prompt diagnosis and repair essential. Recognizing these indicators can significantly assist in the timely troubleshooting of the error code. The first troubleshooting step involves test driving the vehicle under conditions where the auto idle stop system is operational. This feature aims to save fuel and reduce emissions by stopping the engine at idle. To begin this step, you need to ensure that the auto idle stop function is working as intended. During this test drive, allow the system to function and then rhythmically stop the engine using the auto idle stop feature. Observing any irregularities or abnormal behaviors during this process may provide initial insight into the issue. It's crucial to monitor the vehicle's electrical performance while utilizing the auto stop feature, as this can help identify specific patterns or triggers related to the P0A94 DTC. Documenting your observations is important as it informs subsequent steps in the troubleshooting process. Following the initial test drive, the next step is to confirm the status of the DC-DC converter using the Honda Diagnostics System, or HDS. This step involves checking for any fault codes related to the DC-DC converter, particularly the DC-DC converter CST error value. The HDS provides a clear and systematic approach for identifying whether the converter is malfunctioning or operating normally. By cross-referencing these error codes with the initial findings from the test drive, technicians can gain a more comprehensive understanding of whether the DTC is indeed due to a failing DC-DC converter or another system component. Proper diagnostics at this stage are fundamental as they shape the subsequent troubleshooting steps and confirm the validity of ongoing investigations. The third step in the troubleshooting process focuses on inspecting the external circuit connections related to the DC-DC converter. This task is essential to ensure that there are no issues affecting the functionality of the converter due to improper wiring or shorted connections. Start by examining all relevant wiring harnesses, ensuring they are connected properly and securely. Inspect for any signs of wear, such as frayed insulation or exposed wires that may indicate shorting. The direct inspection should include a detailed visual check of terminals and connectors for any corrosion or damage that may disrupt electrical signals. Having a clear understanding of the external wiring circuit can significantly impact the effectiveness of the troubleshooting process and lead to rapid identification of potential faults. Once the external circuit has been examined, the next step is to conduct a thorough inspection of the DC-DC converter itself, focusing particularly on its output circuit. Begin by checking if there are any aftermarket parts or additions connected to the DC-DC Out 1 and DC-DC Out 2 circuits. Aftermarket modifications may often introduce variables that can lead to performance problems or errors being triggered in the system. Next, conduct functional tests on the output circuits to confirm whether the DC-DC converter is generating the correct voltage outputs under operational conditions. If any abnormalities or discrepancies are identified, it may indicate a failure in the converter's output functionality that needs further analysis. A systematic approach during this inspection can either affirm the converter's operational status or identify the need for replacement. The fifth step pertains to inspecting the internal circuitry of the DC-DC converter. Since there isn't a direct method to perform this test, it is essential to rely on the Honda Diagnostics System, HDS, to assess various parameters related to the DC-DC converter. At this stage, the technician should evaluate multiple readings, such as the DC-DC converter ceased error, input error 1, input error 2, output error 1, and output error 2, as reported by the HDS. Each parameter reading provides insight into the overall operational health of the converter and can assist in identifying specific components that may be malfunctioning. All values should be analyzed against the normal operating parameters specified by the manufacturer. If any readings fall outside the normal expected range, it could indicate internal issues warranting further investigation or component replacement. The sixth step involves replacing the DC-DC converter if previous diagnostics have indicated its failure. To confirm the diagnosis, Technicians should install a known good DC-DC converter and then test the vehicle system. This practical approach helps determine whether the replacement resolves the DTC P0A94 issue. If the symptoms or DTC do not reappear, it confirms that the original DC-DC converter was indeed faulty. Should the issue persist despite the converter swap, it prompts further examination of other related components in the electric system. The efficiency of this approach lies in its iterative nature, allowing technicians to isolate components more effectively. After conducting this replacement, observe the system performance closely to ascertain that operational integrity is restored. The final troubleshooting step focuses on the condition of the powertrain control module, PCM. If previous inspections show all external and internal components, including the DC-DC converter, are functioning correctly, the PCM may be determined to be the root cause of the DTC P0A94. Technicians should inspect the PCM for any signs of damage, including visual checks and functional assessments. Understanding that the PCM acts as a command center for various vehicle functions, any malfunction here can mislead diagnostics and signal errors that are not due to actual hardware failures. Addressing faults in the PCM requires utmost care and may involve reprogramming or replacing the module. Validating that the PCM is working as intended is essential to ensure long-term vehicle reliability and performance. After repair work related to DTC P0A94 is completed, it is crucial to conduct a final verification to ensure all issues have been thoroughly addressed. Start by rechecking the vehicle using the Honda Diagnostics System, HDS, to confirm that no DTC codes remain active. This step provides immediate insight into the system's current state following repairs. Following this check, take the vehicle for a test drive under conditions similar to when the DTC was originally triggered. Monitor vehicle performance during this drive to ensure systems are functioning normally and that the DC-DC converter is operating effectively. After the drive, it should be verified that all electrical systems respond appropriately and maintain stable performance levels. If all checks return normal results, it indicates that the troubleshooting and repair process for DTC P0A94 has been successful. To prevent recurrence of DTC P0A94, it is essential to implement routine preventive maintenance practices concerning the vehicle's electrical system. Regular system inspections will help detect early signs of wear or malfunction in the DC-DC converter and related components before they escalate into significant issues. Pay particular attention to the condition of wiring and connectors. Ensuring all connections are secure and free from corrosion can preempt potential electrical faults. Monitoring the performance of electrical components can allow for early detection of symptoms similar to those seen with DTC P0A94. Educating vehicle owners on the importance of timely inspections can help encourage proactive measures, ultimately contributing to the longevity and reliability of their Honda Civic. Moreover, creating a maintenance schedule with recommendations for specific electrical system checks could become beneficial. In summary, addressing DTC P0A94 effectively involves a thorough understanding of both the DC-DC converter's critical role and the interconnected nature of the vehicle's electrical systems. Systematic troubleshooting is crucial, encompassing a series of methodical steps that lead to accurate diagnostics and successful repair. It's vital to diagnose underlying issues thoughtfully and ensure that all components are functioning optimally to prevent similar problems from arising in the future. Furthermore, encouraging preventive maintenance activities will allow vehicle owners to maintain the integrity of their systems over time. ultimately ensuring a reliable and efficient driving experience. Understanding the cycle of diagnosis, repair, and preventive care is imperative in fostering sustainable vehicle performance. This structured approach will not only lead to successful repairs, but also enhance the overall quality of ownership for Honda Civic 2022 Plus drivers. Please like and subscribe to the channel. See you next time!